All right, this is part 2 of the lesson on, actually it's the third video, but it's the second part of the examples for basic trigonometric identities. I want to put one more tool in your toolbox, and this is something you really rarely find in textbooks. I'd be really surprised if it's anywhere on Alex. Let's go back to this very first problem that we worked here. And the original problem was this. Take the fraction sine of x, secant of x over tangent of x, and simplify it. So we got it simplified down to 1. So let's just write this down here. And I'm going to tell you a technique that I started to use a long time ago. I'm sure I'm not the only one to have thought of this, but I didn't find it in a book either. So I have this fraction here, and I would like to, I think that it's equal to 1. But, you know, if you've gone through a lot of steps, sometimes, honestly, it's just not so obvious, especially as a student, because you're just building up your skills with this kind of thing. So how could you tell if these two things are truly equal or not? Well, one thing you might be able to do would be to pick a couple of different values of x and run it through here and see if it turns into a 1. Well, that's all well and good for that one, but how about this one right here? Cosecant square x minus 1, take that quantity and multiply it by sine of x. That's supposed to be equal to cotangent of x times cosine of x. Now, I suppose you could plug in a number of different x values and see if they agree. If they did, that would be confirmatory, but it wouldn't exactly be a proof because you don't check, you can't check all possible points. So here's something you could do. If this is truly an equality, I'm going to do it for this one first because it's a little simpler, but then we'll do the next one. And I'm going to show you a way to use your calculator, leverage your calculator, to get an idea of whether you're right or not. Now, calculators can have some issues. So sometimes with really complicated stuff, they will themselves get confused. But let's take this fraction here. If this fraction equals 1, then if I subtract 1 from each side, it's equal to 0, right? Now, what would happen if I graphed the function 0? Let's just go to our calculator, and I'm going to set my first function here equal to 0 and graph it. It's not a very interesting graph, I'll tell you that. Go to the standard window, and I won't see anything because it's graphing right on top of the x-axis. So if this expression on the left here is really equal to 0, if I were to graph it, I should see this, just an empty screen. So let's give it a try. I'm going to go to the y equals menu, and I'm going to make this fraction sine of x times the secant of x. Now the secant of x is 1 over the cosine, right? So I'm going to have to write this with sine on the top, and then secant and rather cosine and tangent on the bottom. Cosine of x, I am probably going to be safer to use an extra parenthesis here. Actually, I think I absolutely need to. Cosine of x times the tangent of x. So I got to close all those up. So what I've got here is sine on the top, and then the secant is represented by a cosine in the denominator. That's the first thing in the denominator, and then there's also the tangent. And there it is. So if I graph this, so let's go to our standard trig window. What I'm expecting is, oh, I forgot something. I forgot to subtract the 1. Well, this is just as good. This is giving me a constant height of 1, so I'm confirming this equation here. This thing is equal to 1. If I did the subtracting 1 here, though, minus 1, and redraw that, I'll get the empty window. Because what I'm doing, actually, it's drawing a graph that's just right on top of the x-axis. You see that little blinker there? That's telling me it's still drawing that graph on the x-axis. Okay, it's done. So this worked. All right, now let's take this one, for instance. 1 over sine square x minus 1 times sine of x is supposed to be equal to cotangent of x minus cosine of x. So if that's true, if I take this left side of the equation, 1 over sine square x minus 1, multiply it by sine of x, subtract off this side of the equation, cotangent of x, and on the calculator I'm going to have to do that as 1 over tangent of x. 1 over tangent of x times cosine of x in the numerator, so I'll just put that up here. Then that'd be this minus this should be equal to 0. So if I got the simplification right, and it's kind of messy there, but I think it's readable, then this should give me that empty graph as well. By the way, it's probably a good idea to make sure that we're in radian mode, which we are. Now, since we're hoping just to get the 0 graph, it would work anyway, but by default, we're working in radians. So let's be consistent on that. Then, when the time comes when we really need it to be, it'll be in the right mode. Be in the mode that we really need. Okay, so I'm going to type in that function right there. What a mess. 1 divide by sine of x squared. Let's see, and I got to get my parentheses in the right place here. So I'm going to square that sine of x. And then I'm going to subtract 1 and close the parentheses. And I don't know if I started with an open parenthesis or not. I did. Good. So I've got this much typed in. Multiply that by the sine of x. And then I'm going to subtract the fraction. Whoops. Close those parentheses. Multiply that by sine of x, and then subtract the fraction cosine of x. Divide by, whoops, still in those parentheses, divided by the tangent of x. Actually, in these cases, the real challenge is getting the darn thing typed in right. Okay, now if it's typed in correctly, this ought to go. So let's take a look at the graph. If it's not, we'll go back and see if we need to edit. But it's looking good, right? It's still blinking, but I'm not seeing anything other than the x and y axes. And we're done. It worked. So that function, that crazy long thing that I just typed in, it's this whole thing is equal to 0. So that means this and this have to be equal. Well, that's great. So on your problems that need to be simplified, and this is a great way to check your work, say on a quiz or an exam too. You do the simplification, you think you got it right. How can you tell in a hurry? Well, maybe not in a hurry. How can you tell fairly quickly? Type in the left side of the equation minus the right side of the equation into your calculator and see if you get that empty graph. If you do, well, you got an equality. All right, we are now going to do the last 3 examples on my list here. And the next one up is example number 4. Quantity 1 minus cosine squared x times cotangent squared x. 1 minus cosine squared x times cotangent squared x equals cosine squared x. Okay, what we want to do is turn this into this. And you can probably guess what I'm going to do. I want to work this as a simplification problem. So I'm going to take the more complicated side, and I'm just going to keep simplifying it, and hopefully when I'm all done, what I've got left is cosine squared. Now, this one is begging to be changed because of our Pythagorean identities. we know sine squared x plus cosine squared x is equal to 1, and therefore, if you took this equation, subtracted cosine squared from both sides, you have 1 minus cosine squared is equal to sine squared. That is such a common simplification that it should definitely be noted, and eventually, if you work enough problems, you'll memorize it just accidentally, because you'll do it so many times. Okay, so I've got sine squared x times cotangent squared x. And what I did is I used the Pythagorean identities. All right, now the next thing I want to do is, well, sine squared is pretty simple, just as it stands. So what about the cotangent? Well, cotangent is cosine over sine. So I'm going to rewrite this as sine squared x. Now, cotangent is cosine x over sine x. And if I were to square this, then I'd have cotangent squared, right? And that would simply square both of these. So cosine squared x, sine squared x times sine squared. Well, and what I've done here is the ratio identity. And now you can see that sine squared x cancels with sine squared x, and we're left with cosine squared x. And there you have a proof. That's what we were trying to get to. So that takes care of the fourth problem. Okay, the fifth one. We would like to prove that sine x over 1 plus cosine x equal a plus 1 plus cosine x over sine x is the same thing as 2 cosecant of x. Now, let me tell you my dirty little secret on doing trig identities. I don't solve these before I do them in class when I look at something like this, because now I know to a beginner, you look at this, probably, at least I would have when I was first starting with trig identities, and just be overwhelmed by the complexity. But as a seasoned practitioner of the art, I see the patterns that are in here. And so let me tell you what I'm going to do next. Might look clever, but the reality is it is absolutely the standard thing to do. When I look at this fraction, I see a single term down here. I don't have one thing plus or minus another. Now, power, if it were sine squared, it generally would not be a problem. But I don't like having multiple terms down here. So I'd like to rewrite this in a way that doesn't have multiple terms. And this is the standard trick. What I'm going to do is take that denominator that's already there, and I'm going to multiply it by 1 minus cosine of x. Now, whatever multiple I take on the denominator, I'm going to have to take the same multiple on the numerator, or I would be changing the value of this fraction. I don't want to change its value. I just want to change its form. So this and this are the same. Actually, I probably should have written this down again. So this is equal to this, plus I've got to copy this fraction. 1 plus cosine of x over sine of x. And what I have done here is nothing other than algebra. I multiplied top and bottom by 1 minus cosine x on the first fraction. Now, if I multiply these out, what I'm going to do is I'm using this old pattern from algebra. Let's see, I've got the plus first on that one. If I multiply these things out, a times a is a squared. Middle terms, this times this is ab. I said a squared, but I didn't write it. So let's try again. A times a is a squared. This times this is ab plus ab. This times this is minus ab. And this times this is minus b squared. And for those of you who are familiar with this, you probably would go from the left side to the right side in one step, and that's just fine. So when you take a plus b times a minus b, you get a squared minus b squared because the middle terms add up to 0. So that's what's going to happen down here in the denominator. In the numerator, let's see what we can do with this. Maybe I should do one thing at a time though, and so I'm just going to copy that as it is, and then I've got oops, I still got my fractions in 2 pieces here. So this times this is 1. Now the middle terms are going to add up to 0. Cosine x minus cosine x, but this times this is minus cosine squared. And 1 minus cosine squared x is familiar. That's Pythagorean identity again. So 1 plus cosine x over sine x. And what I did here was, well, algebra. I multiplied those 2 things together in the denominator. Okay, then the next thing, I need my equal signs here. This is equal to this. Okay, now the next step in the calculation is this. 1 minus cosine squared is the same as sine squared. And 1 minus cosine squared x, you need to say the x. 1 minus cosine squared x is the same as sine squared x. And in the numerator, sine of x, 1 minus cosine of x, plus 1 plus cosine x over sine x. And what have I done? I have used the Pythagorean identity, the first one. Use the Pythagorean identity, and I've got a sine squared. Now here, I'm going to multiply up and down by sine squared so that I get a common denominator. So once again, just algebra. The common denominator is sine squared. This, it doesn't need to be changed at all. This one, I'm going to multiply by top and bottom by sine, and then both denominators are sine squared. And all I've done here is algebra. Okay, now we're going to use our algebra skills one more time. Sine times 1, sine of x times 1 is sine of x. Sine of x times cosine of x, well, notice the negative, and that'll be critical here. But sine of x times cosine of x is just that. It's sine of x times cosine of x. Then this times this is sine of x. This times this is plus sine of x cosine of x. And the whole crazy mess is divided by sine squared x. Now, that was algebra once again. You're catching on why you take algebra before trig, right? Okay, now notice I have plus sine of x times cosine of x and minus sine of x times cosine of x. Those two add up to 0. And I've got sine of x plus sine of x is 2 sine of x. Be careful with that. That's adding, not multiplying. So 2 sine of x in the numerator. And in the denominator, I have sine squared x, which means sine of x times itself. Okay, well, sine of x and in the numerator, sine squared in the denominator, one factor of sine of x cancels out, so I have 2 over sine of x in the denominator. And once again, this is just algebra. All these steps are algebra until the last one. 1 over sine of x is cosecant of x. So that's 2 cosecant of x. That is what we were trying to prove. And all of these steps are algebra. Not quite sure how to squeeze that in here. Algebra, algebra, and here I used the reciprocal identities. Okay, so that proves the next to the last one, and we've only got one left. Good news is it's going to use a trick that we've already used, so it won't be hard. All right, if you have hung in there till now, my congratulations and thanks to you. So this is our last proof. Sine of x over 1 minus cosine of x is equal to cosecant x plus cotangent x. Okay, warning, warning, warning. There is a mistake waiting to be made here. Sometimes people look at this and they want to say, oh, that's sine of x over 1 minus sine of x over cosine of x. Well, it's not. And of course, those people are not just making things up. They're remembering a similar pattern. If I had this, 1 minus cosine of x over sine of x, so in other words, the very same pattern I have here, except the reciprocal, then I could divide term by term. I'd have 1 over sine of x, which is cosecant of x, and minus cosine of x over cotangent of x, rather sine of x. Cosine over sine is cotangent. And I could just do it in one swoop, this over this and this over this. But here, it's the other way around. I've got two terms in the denominator rather than two terms in the numerator. So I would like to compact that to a single term. Well, good news, that's something we recognize. If you have 1 minus cosine of x or 1 plus cosine of x, you can multiply by the other one of those factors. And it works the same for sine, too. If I had 1 minus sine of x and I wanted a single term, then I could multiply by 1 plus sine of x and get 1 minus sine squared, which is cosine squared. But that's getting ahead of ourselves. So let's just do this the way it's written. I'm going to start with this, and I'm going to move to this. Now, I can't just stick a factor of 1 plus cosine of x in the denominator unless I also multiply the numerator by that. And what I'm doing here is nothing other than algebra. So, I wouldn't really have to know what these functions are to know that that's legal. Okay, once I have that much, then I can multiply this out. On the bottom I have, well, let's copy the top. On the bottom, I have this times this is 1, and then I get that old familiar pattern. Minus cosine of x plus cosine of x. Those are going to add up to 0. And then this times this, 1 minus cosine of x times itself, 1 minus cosine x squared. Okay, and what did I do there? Well, I did algebra. Nothing else. You really don't need to know anything about these functions to do that much. Okay, now 1 minus cosine squared is the same as sine squared. So that gets rewritten here. And that is we're using one of the Pythagorean identities. Namely, we're using sine squared plus cosine squared, sine squared x plus cosine squared x is equal to 1. And then I've got one factor of sine of x in the numerator, 2 of them in the denominator. I may as well cancel one of those factors out. So that becomes a 1, and that becomes just sine of x by itself. Okay, now, notice what we did here. This is algebra. What we did is we transformed this kind of a problem with a single term in the numerator and 2 in the denominator to 2 in the numerator and 1 in the denominator. That's exactly the sort of thing we talked about before. Well, gosh, if you had 2 terms in the numerator and 1 in the denominator, you could divide term by term. So 1 over sine of x can be written as by itself, and then cosine of x over sine of x. That is another step of algebra. And finally, 1 over sine of x is cosecant x, and cosine of x over sine of x is cotangent x. And, oh, actually, I've got two steps there. The first one, what I used was the reciprocal identity. And on the second one, I used the ratio identity. Okay, that is it. We've got a full proof. So we start with sine x over 1 minus cosine of x, and we transform it step by step into cosecant x plus cotangent x, and there it is. By the way, this is actually a form that appears not uncommonly in calculus. So this might look like just kind of busy work to learn how to do this, but all of these transformations that you're learning in this section on identities are actually used by mathematicians, engineers, and scientists in order to get things around into the form that they need for their work. Okay, that is it. If you have made it this far, you have seen all the stuff I had hoped to show you, and I wish you well. You will be able to you'll be able to get a hold of me by email if you have questions, and if I'm getting a lot of things that are common, then I will post some additional helps to Blackboard as well.